Hello, how are we going? Well, we're up to the last module, module 16 of switching, routing and wireless essentials. So it's troubleshooting static and default routes. So we're going to look at packet processing with static routes, and we're going to look at troubleshooting static and default route configuration. So packet processing with static routes. So basically here we're going to talk about hosts talking to one another. And so PC1 addresses a packet for PC3. So the very left PC to the very right PC, and sends it to the default gateway address. Of course, that's because it's a host. It doesn't talk to remote hosts itself, so it uses the gateway to do it for it, of course. When the packet arrives at router 1, it decapsulates the packets and searches a routing table for a matching destination network entry. So, of course, it's going to be looking for 192.168.2 as in its routing table. And so, if the destination IP address matches a static route entry, router 1 will use the static route identity of the next hop IP address or exit interface. So in other words, it will follow its forwarding instructions. If it does not match a specific route, it will then use a default static route if it's been configured. And so basically, you could have just configured on router 1, well, the rest of the world is that away. And so it would have forwarded it towards router 2 anyway. If it does not match any route table entry, then router 1 will drop the packet and send an ISMP message back to the source. So it will say destination network unreachable, probably. So assuming router 1 matched a routing table entry, it encapsulates a packet in a new frame and forwards it out interface S010, which of course is here, towards router 2. Then router 2 will receive the packet on S010 on this interface. It will then decapsulate the packet and do exactly the same process as router 1 did. So we'll need to find a match in the routing table for this network. And so from there, if it finds a match, it will then, of course, identify what instructions it has, and so it might be out this interface or it might be a next hop IP address, whichever one. And of course, it will then re-encapsulate the packet for that link to go to now R3. All right, of course, router 3 will receive the packet, decapsulate it, and searches the routing table for a match. Now, that should be a fairly trivial look because it's a directly connected network. And so, of course, it will the destination will match the directly connected interface, and therefore router 3 searches the ARP table for the layer 2 MAC address of PC3. So, of course, this is the final delivery. It needs to know the layer 2 address of PC3. If no ARP entry exists, then R3 will send an ARP request out of the interface saying, hey, who's got the IP address, whichever one it might be, for PC3? I don't think it actually specifies it. And so then, of course, PC3 will normally respond to that ARP request by you sending an ARP reply saying, hey, this is my MAC address. Router 3 then encapsulates a packet in a new frame, uses the PC3 MAC address as the destination MAC address, and of course its own MAC address as the source. The frame is then forwarded out the interface, and of course it will arrive at PC3, and of course it will do whatever that packet requires to be done. So that's how it works. Now, of course, if it doesn't work, we've got to figure out which of those steps didn't happen for it to get through, basically. So, network changes. So networks fail for a number of reasons. So an interface might fail, a service provider might drop a connection, links can become oversaturated, or someone may make a mistake. So network administrators are responsible for pinpointing and solving the problem. To efficiently find and solve these issues, it is advantageous to be intimately familiar with the tools to help isolate routing problems quickly. So, of course, from PC1, you could try pinging PC3. And so, of course, that will give you feedback whether it works or not, and I'm assuming that it won't because we're talking about troubleshooting. but of course, ping only gives you a binary yes or no answer, doesn't it? It works. I suppose that's a good answer, and you don't need to go any further, at least for your layer 3 information. But of course, no doesn't actually get very specific. Unless you might get a little bit of a hint, you might get a message on the screen saying, network network address unreachable or something along those lines. But it's and it will often display what router sent that back, so that might be of some use. But of course, traceroute is very useful, and so of course it will send packets out, and of course it will tell you which routers along the way it can talk to, and of course the last one that it can talk to, well, the problem's either going to be on that router or the next one along, or the link between them, or something like that. So at least traceroute, of course, will let you isolate the problem to at least a zone, not necessarily exactly the device, but at least an area. Now, of course, that's when you start checking your routers. So show IP route shows you the routing table. So of course, you'd look at router 1 and go, okay, well, it knows how to find PC3's network, or it doesn't, one or the other. And so of course, if router 1 knows, then you might have to check router 2 and see if it knows, and so on. And so of course, all the routers need to know all the information. Of course, it may well not be that information at all, that your packets might actually be getting to the destination, but maybe router 3 doesn't know how to find PC1's network on router 1, and so the reply packet needs to get there as well. So if the request gets there but the reply doesn't get back, well, it's the same end result. And so of course the routers need to have complete information. So show IP interface, of course, will tell you the status of all the interfaces as well as their addressing. And of course, show CDP neighbors is very useful for fault finding, especially if it's a network you don't necessarily aren't intimately have intimate knowledge of. It will actually tell you, well, router 1 is directly connected to, switch 1 and router 2. And so it actually gives you that information. And so it is very useful for troubleshooting. All right, so if we try to solve a connectivity problem, connectivity from PC1 to PC3 fails, extended pings from router 1 to PC3 fail as well, pings from router 1 to router 2 are successful, pings from router 1 to router 3 are successful. And so router 2 table entry reveals the problem and the incorrect static route is removed. A new static route will need to be added. And so we've actually got a static route with 172.16.3.0, and the next hop is via 192.168.1.1. Now, that I suppose is good information. Problem is, router 1's not directly connected to 192.168.1. And so, so this is router 2, sorry. No, that is good information. 172.16. 192.168.1.1. 172.16.2.1. Oh, it is the return route, sorry. I was looking in the wrong route. Static route to 172.16.3.0, which is this network, is actually directing it to there. And so probably the packets are getting through to PC3, but when its replies go, actually router 2 just bounces them back to R3 again. And so, yeah, that's where your problem is, sorry. And so, a faulty route entry. So, of course, you would need to remove this route because it's of no use and you don't want it in there. It's of negative use. It's actually misleading. And so you, of course, would need to do no IP route and the details. So, of course, you do a show run. You can copy and paste, put a no in front. And then, of course, we need to put in the correct information, which, of course, is this. Sorry, I was not interpreting the information correctly there to start with. All right. And so basically, of course, when it comes to fault troubleshooting this problem, it could be any of the 3 routers, and so that's when you, of course, need to check it all, as all of the routers need to be able to find all the networks for it to work, basically. And so, yeah, in this case, it was router 2, but of course, you know, it could have been any of the routers that had a problem. You just need to try and figure out which ones. And so pinging different destinations is certainly a good idea. It's a bit like traceroute anyway. And so, yeah, that's the way that they tested that problem. And so, of course, yes, that information, which of course for the LAN hanging off of R1 was wrong on R2. And so, yeah, not cool. And so, of course, this route is the one that's the LAN that's hanging off of R3, but of course it's got the correct forwarding information. So anyway, not going to be a great deal of a summary, but anyway, a host sends a packet to another host and sends it to its default gateway. Of course, if that destination host is on a different network. When the packet arrives on a router interface, it decapsulates the packet and searches the routing table for a matching destination network entry. If the destination IP address matches a static route entry, the router will use that entry and of course use the forwarding information to forward the packet on. If it does not match a specific route, it will probably use the default route, if there is one, of course use its forwarding information. If it doesn't match anything, so there's no default route and there's no static route or any kind of route for it, it will actually drop the packet. Normally routers will send an ICMP packet back to the source saying, hey, you know, network unreachable, but not all routers will do that, just because some organizations stop their routers from doing that just for security reasons. But anyway, if the router matched a routing table entry, then the router encapsulates the packet and forwards it to the appropriate interface. The packet is forwarded from router to router until it reaches the destination network. And of course, the last router needs to be able to identify the actual destination host. When the packet reaches the destination network, the router will search the routing table for a match. When the destination IP address matches a directly connected Ethernet interface, the router searches the ARP table for that layer 2 MAC address. If no ARP entry exists, it will send an ARP request. The destination host responds with an ARP reply containing its MAC address, and then the router can encapsulate the new frame. It's got all the information it needs. It uses the MAC address of the destination host as the frame destination, and of course its own MAC address as the source address. The frame is forwarded out the appropriate interface, and of course the packet will arrive at the NIC of the destination host, and of course will be processed. Okay, so some common iOS troubleshooting commands you can use to troubleshoot static and default routes are ping, traceroute, show IP route, show IP interface brief, and show CDP neighbors detail. And so that, of course, will hopefully get the information you need so you can then fix whatever problem there might be. Okay, that is the last chapter for CCNA 2, or Switching, Routing and Wireless Essentials. So I'll see you again for CCNA 3. Have a good one.